Welcome to Lesson 2 on quotient of powers. Here we will develop a rule for the quotient of powers. So we will expand the following to determine a pattern when dividing powers with the same base. So number 1, we have 5 to the 8 divided by 5 to the 6. So this means that we have 5 multiplied by itself 8 times. Divided by 5 multiplied by itself 6 times. Now since 5 divided by 5 is 1, then we can cancel them off. And we can continue to do that as long as we have a 5 in the numerator and a 5 in the denominator. Now doing that leaves me with 5 times 5, which is 5 squared. Now for number 2, we have 9 to the 5, which is the same as 5 9s being multiplied together, divided by 9 squared, which is 9 times 9. Now canceling a 9 in the numerator with a 9 in the denominator, we are now left with 3 9s. 9 times 9 times 9 is 9 cubed. So what do we notice? Well, when I'm dividing two powers with the same base, they end up with a single power, where the exponent is equal to the difference of the other two exponents. 8 take away 6 is 2, and 5 take away 2 is 3. So I'm going to say that the number of bases is equal to the difference of the exponents. Now, is the same true for negative bases? Here we have negative 7 to the 10 divided by negative 7 to the 5. So this means that I have 10 negative 7s being multiplied together in the numerator. And in the denominator, I'm going to have 5 negative 7s being multiplied together. Now, negative 7 divided by negative 7 is 1. So I can cancel, like I did with the other two questions, with the negative 7 in the numerator, negative 7 in the denominator, until I'm left with 5 negative 7s. Now, since 10 take away 5 is 5, then the same rule applies with negative bases. We subtract exponents. So now let's look at the quotient of powers exponent law. Well, in words, we can say that when we divide powers with the same base, we subtract the exponents. And the mathematical definition states that if m and n are whole numbers, where m is greater or equal to n, and a is not 0, then a to the power of m divided by a to the power of n is equal to a to the power of m take away n.